Welcome back. This will be the third session on Chapter 7, and we'll be talking about estimates and sample sizes some more. What we want to do now is go through and look at a situation where we determine the margin of error. Let's just use the data we've been working with on the M&Ms. Hopefully I haven't made anybody hungry or have a snack attack kind of a thing at that point. But the margin of error is going to be defined as E for a 95% confidence interval level. We'll put in the 1.96 for 90%, it'd be the 1.645, and with a 99%, it would be the 2.575. That's going to be multiplied by the square root of PQ over N. Our estimate of P was 20. We had 20% reds, and Q was 0.8, and then our sample size was 100. So if we calculate this out, 1.96 times, this turns out to be the square root of 0.0016 when you multiply all that out. So the square root of that is going to be 0.04. So you multiply these things out and you get 7.84. So that's our margin of error, which is about, as we looked at it earlier, that was about 8, and that's what we actually used. We did the mean minus the margin of error, the mean plus the margin of error, and we got 12 to 28. So technically it's going to actually be something like a 12.16 to 27.84, which, they're basically the same there. Now, this formula actually has got some more use to it, because it was E is equal to the confidence interval, which was our 1.96, that's a constant, times the square root of P, square root of Q over N. Now, before we go too far on this, I want to go through and point out to you that this is, you'll probably see a test question on this that asks you, where is this the maximum? And because P and Q are related, P is equal to 1 minus Q, or Q is equal to 1 minus P, however you want to look at it, they get the maximum value at 0.5 times 0.5, because that's 0.25. Okay? If you drop down to 0.46 times 0.6, that's going to be equal to 0.24, which is slightly smaller. Multiply two numbers, P and Q, where P is equal to 1 minus Q, 25 or 0.25 is going to be the largest that you're going to see on that. So again, you may see a test question related to that. But let's go through and do some manipulation here. First of all, we want to solve for this value of N. We want to get this value. I want to solve for that. Okay? So to do that, divide by 1.96, E over 1.96. And you square that, and that's going to give us P hat Q hat over N. So move N over here, move this down here. We find out that N is going to equal to P hat Q hat divided by E over 1.96, and that value squared. Okay? Now, where is this useful? Well, someone comes up to you and they tell you, they say, well, I like what you've been doing with M&Ms, but I want you to go through and I want to be more specific. I want to get a better estimate. How many M&Ms, how many bags of M&Ms, how many M&Ms do I have to look at to get this confidence interval that we looked at earlier? You know, that confidence interval earlier was at 7.84, and they say, I want that cut in half. I want to have a 3.92 confidence interval, or instead of that. So remember that that was the measurement of E here. So let's just plug this value in for E. We know these values, they're 0.2 and 0.8. So that's going to be 0.2 times 0.8 divided by 3.92 over 1.96. You can divide that out. That's going to be a 2 and square that. So that's going to be over except for the fact that that's 0.0396. So that's going to be 0.0396. This is going to be the value of 0.02 0.02 squared should be 0.0004. So we're going to have 0.16 divided by 0.0004, and if we divide that out, then we're going to get an N, which is 400. Okay? So what that means is that in order to cut our confidence interval down by a factor of 2, we're going to have to double our sample size. And you can see that from the formula here, because it does take the N is going to be a factor of this squared. So you can see that does make sense. So basically that just gives you a good rule of thumb to go along with that. Okay, so there's still some things I want to share with you about this chapter, so I'll come back for a fourth session here. We will be right